Hi students, welcome to the session here at Infinity Learn by Sri Chaitanya. I'm Aniruddha sir, your physics faculty here. And today we are discussing the 29 January Shift 1 paper for this 2024 January session. So let's get started with the questions. The first one says the de Broglie wavelength of an electron is the same as that of a photon. If the velocity of the electron is 25% of the velocity of light, then the ratio of kinetic energy of electron and the kinetic energy of the photon is going to be what? So over here, we know basically an electron is a particle, so its kinetic energy of the electron would be half mv square. Now the velocity of the electron is said to be 25% of the velocity of light. So v is equal to 1/4 of the speed of light. So if we put that in, I can write it as half m into c by 4 whole square. That is the kinetic energy of the electron. What about the kinetic energy of the photon, my bad. Kinetic energy of the photon is equal to P into C, its momentum into the speed of light. We want technically the ratio of these two over here. So let's do it over here. Kinetic energy of electron by kinetic energy of the photon is half mc square divided by 16, because you have a 4 square there, and you have a P into C. Cancel these C's out. So you get Ke by Kph photon is m by 32 into the momentum P over here. Now this here refers to the momentum of the photon. However, the momentum of the photon will be the same as the momentum of the electron because their wavelengths are the same. The de Broglie wavelengths are same. Since we know P is equal to h by lambda, that tells you that the momentum of the photon is equal to the momentum of the electron as well, because their lambdas are equal. So over here, if I consider this to be the momentum of the electron, then I can write that as mass into velocity of the electron. Velocity of the electron is again c by 4. See, we put there's an extra c over here. We put a c by 4 up top, cancelling out the MCs. This 4 goes out, takes away an 8. So at the end, you're left with kinetic energy of electron to that of photon is 1:8. So it is option D. Next question says if the radius of curvature of the paths of two particles of same masses are in the ratio of 3:4, then in order to have constant centripetal acceleration, their velocities will be in the ratio of what? So we know centripetal acceleration is v square by r. If the centripetal acceleration is constant, then we can tell clearly that v square proportional to the radius, v square is proportional to r, which just means that v1 by v2 whole square would be equal to r1 by r2. R1 by R2 is given as 3 by 4. So V1 by V2 will just be the root over of 3 by 4. So it should be root 3 divided by 2. It is option C. Next question for us says that a thermodynamic system is taken from an original state A to an intermediate state B by a linear process as shown over here. Its volume is then reduced to the original volume from B to C by an isobaric process. What is the total work done by the gas from A to B and B to C? So you want work done in this path and this path. Now if you look at it, this path AC over there has 0 work done because it's an isochoric process. So if you're looking for the work done by AB and BC, that is equal to the work done for the full cyclic part, because this contributes no work. So we can directly find the work done from a P versus V graph by the area under the graph, area inside it. So the work done, W is equal to the pressure over here, this half into base into height. So half into base is 4 units, 4 meter cube, multiplied with the height is 4000 to 8000, but the unit is dyne per centimeter square. So dyne per centimeter square, 1 dyne per centimeter square is actually equal to 10 to the power minus 1 Newton per meter square. That's the conversion factor. You can put dyne is 10 to the power minus 5 and centimeter square is 10 to the power minus 6. 10 to the power minus 4. Based on that, you would get it. So we put that as the difference is 4,000 into 10 to the power minus 1. Simple, cancel it out, take one of the zeros here, 2 into 400 would give you 800 joules. So the answer is option C, 800 joules over here. Next question for us states that a body starts moving from rest with a constant acceleration, covers a displacement s1 in the first p minus 1 seconds and s2 in the first p seconds. The displacement s1 plus s2 will be made in how much time? So since it's starting from rest, I can write s1. S1 for us is half at square, ut plus half at square, u is 0. So the t is this p minus 1. That is your S1. And S2 is the distance traveled in the first p seconds. So you have half a into p square. You're looking for S1 plus S2. That would be half into a into p square plus p minus 1 whole square, which would give you p square minus 2p plus 1. So S1 plus S2. Now you want this S1 plus S2 is travelled in how much time? So in place of S1 plus S2, I can write half at square. That t is the time in which it will travel S1 plus S2. And if I put what S1 and S2 is equal to, I'll have half a 2p square minus 2p plus 1. Half a's can be cancelled out. T square is equal to that 2p square minus 2p plus 1. So you can put that in. So t will be root over of 2p square minus 2p plus 1 seconds. Next question says, given below are two statements. If a capillary tube is immersed in first in cold water then in hot water, height of capillary tube will be smaller in hot water. And next, if you do it over here, will it be smaller in cold water? So obviously we know the height, the capillary rise is 2t cos theta divided by r rho g. Now in this case, you see that surface tension is lesser in hot water and more in colder water. So if surface tension is less, height will also be less. So this statement is correct because rise is smaller in hot water. And this says it is smaller in cold water, which will be incorrect because over here in colder water, your surface tension increases. So the height would also increase. So statement 1 is correct and statement 2 is false. Option C. Next question says that we have list 1 and list 2 with all the 4 Maxwell's equations. You just have to relate the correct Maxwell's equation with the correct name for it. So this one you can directly do. This is your Ampere-Maxwell law. Ampere-Maxwell law. This E dot dl. E dot dl is technically the EMF. EMF is d phi b dt. That is your Faraday's law. E dot dA is equal to Q by epsilon naught. You studied it all the way back in electrostatics as Gauss law. So it is the Gauss law for electricity. And lastly, B dot dA is 0, which tells you that magnetic monopoles cannot exist. That is the Gauss law for magnetism. So let's see what matches us. A with 4, A with 4, B with, this is 3. A with 4 and B with 3, it's going to be this one. Option C. It has overlapped a bit here, but it is technically that option. Option C there. Next question says, the explosive in a hydrogen bomb is a mixture of H2 and H3, so deuterium and tritium and lithium in some condensed form. Chain reaction is given by this. During this entire explosion, what is the energy released in this entire thing? Now, even though you have been given 2 separate equations, you should try to convert it into a single equation. How do you do that? You do that by technically adding the 2 equations and seeing what is the overall equation that you get. You see, you have a tritium on this side and a tritium on this side. So they kind of cancel out when you add them up. So it is just this tritium that is giving rise to this. And on the other side, this neutron, whatever you had inserted before, that is emitted out at the end. So that also you ignore. Meaning if you add them up, the final relation, the final reaction that you would get would be the lithium 6 plus the deuterium, and that is just going to give you 2 heliums. 2 heliums, that's it. Because everything, whatever neutron you put in, that neutron has been taken out at the end. Similarly, whatever deuterium, whatever tritium you got, that has been reused again. So its energy, you won't really be concerned about that. This is the main process that you're dealing with. So when you're looking for the energy released, you just want what is the energy release in this from the mass defect. So we can get the energy released is equal to energy of lithium plus deuterium, that is 6.01690, 6.01690 plus the mass of deuterium, which is given as 2.01471 and minus 2 times of the helium. So helium is given by this. So minus 2 into 4.00388. Did I get it correct? Yes. So see the first parts before the decimal, I don't really need to bother about. It's going to be 8. That's also, oh my bad, 2 into. That's also going to be 8. What I'm mainly concerned with is 0.01690 plus 0.01471 minus 2 times of 0.00388. So that is technically, if I add them all up here, 1690 plus 1471, that's going to give you 1, 16 here, put 1 up, so 10, 11, 1 here, 3. 3161, and from that you subtract 2 into 388. 2 into 388 would be 776 minus 776, 38, yes, 776. So what do we get out here? We get a 5, bring it down, 8, this goes with an 8, comes down, 8 to 1 it would be a 3. And here it comes 1, so it's 2385. So you are going to get 0.02385, and of course you have the into 931.5 mega electron volt over this entire thing. So multiply with 931.5. You can get a rough idea. It's somewhere 2300, close to that, but a little less because you're not multiplying with 1000, you're multiplying with a little less than 1000. So only possible option is option D, 22.22 mega electron volts. Next question says that two vessels A and B are of the same size and are at the same temperatures. A contains 1 gram of hydrogen, B contains 1 gram of oxygen. PA and PB are the pressures of the gases in A and B respectively. Then what is the ratio of PA is to PB? Now in the same vessel means they have same volume and they are also at the same temperature. So if I think about the relation of PV is equal to nRT for both of them, VT are constants. So the only thing that the pressure is going to depend on is the number of moles over here. They both have the same mass, 1 gram. But this number of moles can be written as mass divided by the molar mass. Now since for both of them the mass supplied is the same, you know that the pressure is just inversely proportional to their molar masses, which means PA by PB is just equal to inversely proportional. A was hydrogen, inversely proportional to their molar masses. So molar mass of oxygen by molar mass of hydrogen. So PA by PB comes out to be molar mass of oxygen is 32. This one is 2, take it out, you have 16. That is the answer, option B, 16. Next question says that a galvanometer having a coil resistance of 10 ohms shows a full scale deflection for a current of 3 milliamperes. For it to measure a current of 8 amperes, what is the value of the shunt? So pretty straightforward direct formula for a shunt resistance. S is equal to Ig into G divided by I minus Ig. Put your values in here. Ig, the shunt, the galvanometer resistance was 3 milliamperes, so 3 into 10 to the power minus 3. Multiplied with the galvanometer resistance was 10 ohms divided by I minus Ig, which is 8 minus 3 into 10 to the power minus 3. Sorry, 8 minus. This 8 minus 3 into 10 to the power minus 3, you can approximate it to be 8 only, because this quantity is negligible as compared to 8. So all we are looking for is 30 by 8 into 10 to the power minus 3. The only possibility there is option C, 3.75 10 to the power minus 3. Next question says that a convex mirror of radius of curvature 30 centimeter forms an image that is half the size of the object. The object distance is how much in this case? So over here, first and foremost, we know magnification is equal to minus V by U. Magnification is minus V by U. Magnification is given as half. It's half the size of the object. So magnification is half, and it is plus half because we know for a convex mirror, the image is diminished and it is erect. So I know this is plus half is equal to minus V by U. So V is equal to minus U by 2. Let's hold it there. The radius of curvature is given as 30 centimeter, which means the focal length is 15 centimeter, and it's a convex mirror, so it's a positive focal length. Now where do we go to? We go into the mirror equation. 1 by V plus 1 by U is equal to 1 by F. V is minus U by 2. So that's it, makes it minus 2 by U plus 1 by U is equal to 1 divided by 15. So we get minus 1 by U is 1 by 15. So U is equal to minus 15 centimeter. So our answer here is option A. It is minus 15 centimeter over here. That's the object distance. Next question says that a biconvex lens of refractive index 1.5 has a focal length of 20 centimeter in air. If its focal length when immersed in a liquid of refractive index 1.6 is going to be what? So we use the lens maker formula over here, which says that 1 by F is equal to N2 by N1 minus 1, 1 by R1 minus 1 by R2. Now in the two cases that are provided, this part is going to stay the same. That depends on the geometry of the lens. It's only this part that is going to change. Let's call this, consider this as a constant C, just for now, because that will help us in writing too many steps. In the first case, you have 20 centimeter. The refractive index of the lens is 1.5 divided by it's in air, so it's 1, N1 is air, minus 1 into that C. So this is 1.5 minus 1 is 0.5. So C, if you calculate, you'll get it as 1 by 10 from here. Just send the 0.5 down. 0.5 into 20 would be a 10. C is equal to 1 by 10. Post that, in the next case, we can reuse the C, because in the next case, it is dipped in a liquid where the refractive index is 1.6. So in our new case, F dash, N2 by N1, it is 1.5 by 1.6 minus 1 into that C. So 1 by F in this case would be 1.5 minus 1.6, which is going to be minus 0.1 divided by 1.6 into C. So cancel this out, and C was equal to 1 by 10. So F comes out to be minus 160 centimeter. If you put C is equal to 1 by 10 over there. So the answer is minus 160 centimeter for this. Next question says that the electric current through a wire varies with time as I is equal to I naught plus beta t, where I naught is 20 amperes, beta is 3 amperes per second. Amount of electric charge crossing through a section of the wire in 20 seconds is. So we know that the charge flowing is equal to integration I dt. So that's what we do here. Take an integration, time is 20 seconds, so 0 to 20. And the current is I naught plus beta t. So it is I naught is 20 plus beta t, beta is 3 into t dt. So what do we get? We have, okay, let's directly go past the integration and do it. So we have the 20t, because integration 20 will give you 20t plus 3t square by 2, limits going from 0 to 20. We put the values in, we have 20 into 20, 3 into 20 into 20, 20 square divided by 2. This leaves behind a 10. So 400 plus 600, you will get the total as 1000 coulomb over here. Next question is on moving coil galvanometer. It says deflection in a moving coil galvanometer falls from 25 divisions to 5 divisions when a shunt of 24 ohm is applied. The resistance of the galvanometer is how much? So you have the galvanometer here, and originally it was taking in 25 divisions. So let's assume just hypothetically that each division is 1 ampere. So it was taking 25 amperes to come in. 25 amperes was coming in. At the end, it won't matter what I am choosing as the conversion thing. You can take it as 1 ampere. So originally this was coming in. Now, as soon as you added a shunt, and that shunt has to be in parallel because it reduces galvanometer current. As soon as you added a shunt, you see that the galvanometers, this reading reduces to 5 divisions, which means now the galvanometer is only getting 5 amperes, which means the shunt is taking up 20 amperes. You know the potential difference across the galvanometer should be equal to the potential difference across the resistor. So just by that logic you can do, we want the resistance. So this Ig into G should be equal to, it's a very same logic. It's that IR into R, where IR would be this 20 ampere that goes into this resistance R. Resistance is given as 24 ohm. So you're looking for this G. G is equal to IR was 20 multiplied with 24 divided by the current Ig was 5 amperes. Take it out with a 4. 4 into 24 would give you 96. It is 96 ohm. That's the resistance of the galvanometer. Next question says, a block of mass 100 kg slides over a distance of 10 meters on a horizontal surface. If the coefficient of friction between the surfaces is 0.4, then what is the work done against friction? So pretty straightforward question. We know if there is a block here, coefficient of friction is mu. Block has a mass m. Then the frictional force backwards is mu mg. So you know the force, you know the displacement. So the work done by friction is just mu mg into displacement. Mu is 0.4. Mass is given as 100 kg. Acceleration due to gravity is 10. And the displacement is also 10 meters. So we get, take this out with one of them. So 4 into, so we have 4,000. 4 into 1000, that is 4000. That is the work done by friction. And generally it's going to be a negative work done. Since you have been only asked for magnitude, you stay with that. Next one says, two charges 5q and minus 2q situated at points 3a, 0 and minus 5a, 0 respectively. Electric flux through a sphere of radius 4a having center at the origin is how much? So suppose this is your coordinate axis with this as the origin. This, you have a circle and the radius of the circle is 4a. Now based on that, if you plot the position of the points, you will see 5q is at 3a. So at a distance 3a, you have 5q. And this minus 2q is at a distance of minus 5a. So minus 2q would be over here. It would be at minus 5a. 5a on this direction. So you see the internal charge, the charge enclosed is only 5q. And we know the flux is equal to the charge enclosed by epsilon naught. Since it's only the 5q charge enclosed, so 5q divided by epsilon naught. It is option B. Next question says, a capacitor of capacitance 100 microfarad is charged to a potential of 12 volts connected to a 6.4 ohms inductor to produce oscillations. What is the maximum current in the circuit over here? We know that in an LC oscillation, maximum current formula is equal to Q naught into omega. Q naught into omega, Q naught being the full maximum charge of the capacitor. Qm into omega. So what is the maximum charge of the capacitor? It is just going to be CV naught. C into V over here. This is the maximum voltage possible. And this is here. CV into omega. Since it's in resonance over here, the omega value, it's a LC circuit, is 1 by root LC. So it is just V root over of C by L. Put the values in. V is 12. The capacitance is 100 microfarad, so 100 into 10 to the power minus 6 divided by the inductance is 6.4 millihenry. So 6.4 10 to the power minus 3. Remove this, make it 10 to the power minus 4. Now 10 to the power minus 4, so this is 10 to the power minus 4, this is also 10 to the power minus 4. 100 into 10 to the power minus 6, make it 10 to the power minus 4, cancel out with this. So you have just 1 by 64, that comes out as 8. So 12 by 8 is 3 by 2. So you have 1.5 amperes as the answer for this. 3 by 2 is 1.5. That is the maximum current. Next question here says, in the given circuit, the breakdown voltage of the Zener diode is 3 volts. What is the value of IZ? IZ being the current that flows through here. Now, if the breakdown voltage is 3 volt, that means the Zener diode maintains the potential difference between these 2 points at 3 volts. Which means to this 1 kilo ohm resistor, the available voltage is technically 10 minus 3 volts, because 3 volts is going across this resistor, that means. So 10 minus 3 volts divided by, so if the current here is say I, and let's consider this current is IR, then I is equal to 10 minus 3, the applied voltage minus the voltage that the Zener diode maintains across it, divided by 10 to the power 3, that is 7 milliamperes. That is the total current flowing out. Now you want what is the current flowing through the Zener diode, but that's not how we directly go for it. Find out what is the current IR. So the Zener diode maintains 3 volts across this point. So there's a 3 volt potential difference across this resistor. So IR is going to be 3 divided by 2 kilo ohms, 10 to the power 3. That is 1.5 milliamperes. Now look at this I. This I is what is breaking up into IZ plus IR. If you look up the junction over here, this I is equal to IZ plus IR. So you want the IZ. IZ is just I minus IR. So I is, we got 7 milliamperes, minus IR is 1.5 milliamperes. So IZ comes out to be 5.5 milliamperes. That is the answer. Let's go to our next question now. It says, at what distance above and below the surface of the earth a body will have the same weight? Same weight means its acceleration due to gravity at that height or that depth will be the same. Let's assume that height or depth be equal to h. Then at a height above the earth's surface, the acceleration due to gravity is given by g r square by r plus h whole square. And at a depth below, it's given by g into 1 minus h by r. So they are equal because the weight is equal at both of those points. Take the g's out. I use a little manipulation. Here I do r minus h by r, and then cross multiply the r over to the other side. I have r cube is equal to, here you will have r minus h into this r plus h whole square goes over to the other side. I write it separately. R plus h into r plus h. Reason I do that is I can make it r cube is equal to a minus b into a plus b, that is r square minus h square into r plus h, that is r cube is equal to r cube plus r square h minus h square r minus h cube. Take the r cubes out. So you have this equal to 0, so you can cancel out 1 h each because you'll have that equal to 0, so you can take out one of the h's. So you are effectively left with h square plus rh minus r square is equal to 0. So you're looking for that height. Apply your Sridharacharya formula. You will get h is equal to minus b, b is r, minus r, plus minus root over b square minus 4ac, b square is r square, minus 4ac, so minus 4 into this, so minus 4 will get plus 4, 4r square into 1, plus 4r square. divided by 2 into A. A is just equal to 1, so divided by 2. So we get H is equal to R common minus 1 plus minus root 5 here, because this would be R root 5, 5R square coming out would be R root 5. I take it out, divided by 2. Obviously the height can't be negative over here. So that is why it is H is equal to root 5 minus 1 divided by 2. So I think we have an answer for that. Yes, it is option D. Let's go for our next question. It says the resistance R is equal to V by I, where V is 200 plus minus 5 volt and I is 20 plus minus 0.2 amperes. Percentage error in the measurement of R is how much? So it's pretty simple. You can see it's simply a division over here. So the percentage change in R is equal to percentage change in V plus the percentage change in I. Percentage change in V is 5 by 200 into 100 plus percentage change in I is 0.2 by 20 into 100. Take this out. This goes out with a 5. So we have 5 by 2, that is 2.5 plus 0.2 into 5, that is 1. At the end you get 3.5%. So it is option A over here. Next question says that the potential energy function of a particle in a region of space is given as U is 2x square plus 3y cube plus 2z. Here x, y and z are in meters. Magnitude of x component of force acting on the particle at P equal to 1, 2, 3 is how much? So we just want the x component of the force. How do you get to the x component of force from the potential function? Simply the x component of force is minus del u del x. So if you differentiate this quantity with respect to x, you will just have the 4x over here. These all will go to 0. So that is equal to minus 4x. You want it at this coordinate where the x value is 1. Put x is equal to 1 and your answer comes out to be 4. Let's move to our next question. These are the numerical type questions. It says when the displacement of a simple harmonic oscillator in 1/3 of its amplitude, then the ratio of total energy to the kinetic energy is x by 8. X is equal to how much? So we know the kinetic energy formula. K is equal to half m omega square a square minus x square. Now it is 1/3 of its amplitude, so x is equal to a by 3. X is equal to a by 3. So over here I have half m omega square a square minus a by 3 whole square, which makes k is equal to half m omega square a square minus a square by 9, which will make it 8 a square by 9. That's the kinetic energy. And what is the total energy? The total energy formula is simply half m omega square a square. If you take the ratio of total energy to kinetic energy, you'll see the half m omega squares will cancel out. So I'll still write it here. Half m omega square a square divided by half m omega square a square kinetic energy into 8 by 9. Half m omega square a square cancel out. So you have 9 by 8 remaining. So x is equal to 9. Next question says that a square loop of side 10 cm, resistance 0.7 ohms is placed vertically in the east-west plane. Uniform magnetic field of 0.2 Tesla is set up across the plane in the northeast direction. The magnetic field is decreased to 0 in 1 second at a steady rate. Then the magnitude of the induced EMF is how much? So it is kept in the east-west plane, and since the magnetic field is in the northeast direction, you can understand that the angle, if this is the area, this is the east-west direction. If the magnetic field is pointing in the northeast is it? Northeast direction, then the angle the magnetic field makes with the area is 45 degree. You want what is the EMF generated when the flux is reduced to 0. So your goal is mainly to find the flux. How do you find the flux? So EMF is equal to minus delta phi by delta t, which is minus phi phi final minus phi initial divided by delta t. Final flux is 0 because it's decreased to 0. You just want initial flux in the very beginning. So what is that given by? So the negative and negative will make it positive. Initial flux formula is BA cos theta. B is 0.2 Tesla. Area is, 10 centimeter square. So it is 0.1 square. So 0.1 into 0.1 multiplied with cos of theta. The angle is 45 degree. So that is cos of 45 is 1 by root 2 divided by the time taken for that to happen is given as 1 second. So it is 1 over here. So take these out and put it as a 10 to the power minus 3. Root 2 and 2 cancel out, you will get a root 2 out. So root 2 into 10 to the power minus 3. So x is equal to 2. Next question says that in a test experiment on a model airplane in a wind tunnel, flow speeds on the upper and lower surfaces of the wings are 70 meters per second and 65 meters per second respectively. If the wing area is 2 meters square, then the lift of the wing is how much? So this is pretty straightforward from Bernoulli's theorem. We know that the pressure difference delta P is always half rho V2 square minus V1 square. This is the standard formula for pressure difference because of different flow rates. So from there, what do we get as the pressure difference? Half into rho is given as 1.2 into V2 square minus V1 square is 70 square minus 65 square. So 70 square, 65 square, and delta P, the pressure difference is what is making the wing. You want the force, a force associated with this area. So we know pressure is equal to force by area. So I'll put that in here. Force divided by the area is given as 2. So I can cancel this 2 out. So F is just equal to 1.2 into 70 square is 4900 and 65 square is 4225. It is 4225. So that makes it 1.2 into 675. 1.2 into 675. 1.2 into 675 would be 1 into 675 is 675. 2 into 675 is 1250. So 0.2 into that would be 125. So it is 675 plus 125. At the end, you would get it as 800 if you calculate it. So the force is 800 newtons. Let's head to our next question. Given a 16 ohm wire is bent to form a square loop, a 9 volt battery with internal resistance of 1 ohm is connected across one of its sides. If a 4 microfarad capacitor is connected across one of its diagonals, then the energy stored by the capacitor would be x by 2 microjoules. Then x is equal to how much? So it's all about constructing the diagram. Since it's 16 ohms and you're bending it in a square, you can think of it to be like this. To be like this, and each one would be 4 ohms. Each one would be 4 ohms over here. And you're connecting a cell across one of the ends. The cell itself has an internal resistance of, I think it's provided as 1 ohms. The cell has 9 volt battery. Cell has a 9 volt battery over there. So let's assume that over here, first find what is the total, you're connecting the capacitor over here. Let's just plot it all out. Let's find what is the equivalent resistance so that we can find what is the current that is being drawn over here. Okay. So over here 4, 4, 4, they are in series because see nothing will flow through the capacitor in the steady state. So 4, 4, 4 in series, that's 12, 12 in parallel with the 4 ohms. So you have 12 into 4 by 12 plus 4. This is 16 over here. This will leave with a 4. This will give you a 3. So up top, this entire resistance is 3 ohms. Along with that, you have a 1 ohm in series. So the total equivalent resistance becomes 4 ohms. You have a cell of 9 volts. So the main current coming out is 9 by 4 amperes. That is the main current coming out. Once that current comes out, you can use some nodal analysis method that let this point be at 9 volts. So this point is also at 9 volts. This point here, before your internal resistance is at 0 volts. So across the internal resistance, there will be a potential drop of I into that R. So over here, it's actually a potential gain over here because we're going in the reverse direction. It would be 9 by 4 volts over here. Similarly, it would be 9 by 4 volts here because I into R, 9 by 4. So from 0, it should increase by 9 by 4 volts. So here also it's 9 by 4 volts. Now let's find out what is the current that flows in, say, this part of the circuit. Let's call it I1. Same current will flow through this part. What is that I1? That I1 is going to be equal to, so in a parallel network, the current through one line, one path is equal to the other path, resistance of the other path, so 4 divided by sum of the total resistance, so 4 plus 12, so 16, multiplied with the main current, which is which we had got as 9 by 4. This is the current flowing in this path over here, which if you cancel it out, you'll have a 9 by 16. That is the current that flows in this wire. So because there's a current flowing of 9 by 16 in that wire, you can find what would be the potential drop across this resistor. It would be that I1 into the 4 ohms. So I1 into 4 over here, so delta V across, let's call it R1, delta V across R1 would be I1 into 4, that is 9 by 16 into 4, that is again equal to 9 by 4 volts. So it was 9 by 4 volts here. It increases by another 9 by 4 volts across this. So by the time it gets to this point, you have 9 by 2 volts. 9 by 4 plus 9 by 4. 9 by 4 was already here. Again increased by 9 by 4. It will now become 9 by 2. Now the voltage across the capacitor is 9 minus 9 by 2 volts. It is 9 minus 9 by 2 volts. So voltage across the capacitor is 9 minus 9 by 2. That is equal to 9 by 2 volts. That is 9 by 2 volts. You're looking for the energy stored in the capacitor. Energy stored in the capacitor is half CV square. C is provided to us as 4 microfarad. It's half CV square. So the energy C into Vc square, half into 4 into 10 to the power minus 6 multiplied with this Vc square, that is 81 by 4. Cancel the 4 out. So you have 81 by 2 into 10 to the power minus 6. So you have to represent it as x by 2 microjoules. 10 to the power minus 6 takes care of that micro. You have the 2 down below. So x is equal to 81 for this question. Next one says the magnetic potential due to a magnetic dipole at a point on its axis situated at a distance of 20 centimeter from its center is 1.5 into 10 to the power minus 5 Tesla meter. Magnetic moment of the dipole is how much? So pretty direct formula based question. We know voltage due to a magnetic moment, due to a magnetic dipole is mu naught by 4 pi. We are dealing about the axial point. So it's a P divided by R square. You can even write it as M divided by R square actually. The formulas are completely analogous to the electrostatic formulas. Even if you would have forgotten the magnetic, you can just relate it with electrostatics. So we have been given the potential as 1.5 into 10 to the power minus 5. Mu naught by 4 pi, mu naught is 4 pi into 10 to the power minus 7 divided by 4 pi into that magnetic moment divided by the R square over here. R is 20 centimeters, so 2 into 2, 10 to the power minus 4. So we can take the 4 pi's out from here, something else. The 10 to the power, 20 centimeter will just leave behind a 10 to the power minus 2. 10 to the power minus 1, so it's 2 into 10 to the power minus 1. So square of that would be 10 to the power minus 2. That leaves behind 10 to the power minus 5. 10 to the power minus 5 goes with this. So you are left with m is equal to 4 into 1.5. That is equal to 6. So it is going to be 6. That is the answer for this one. Next question says, a ball rolls off the top of a stairway with a horizontal velocity u. The steps are 0.1 meters high and 0.1 meter wide. Minimum velocity u with which the ball just hits the step 5 of the stairway will be how much? So over here, if you have the stairways, you want the ball to come off, and if you wanted to hit the fifth one, it should just cross the fourth one. Then it will hit the fifth one. So the height, if each height is 0.1 meter, then the height that you are technically studying for, is 0.4 meter, not 0.5. Your criteria is the fourth step. It needs to cross the fourth step. So the height is going to be the fourth step over here, right? In that case, this is actually 1, 2, 3, 4. It should cross this and fall, my bad. Then you would have the fifth step. So your height is this, and the distance it has to travel is the same way, 1, 2, 3, 4. So your distance to be traveled, or what we call as the range, because at that point, it should be just grazing along it. So this should be the range, this should be the height. We're doing for the fourth step, because if it crosses the fourth, it will land on the fifth. So that is also 0.4 meter, because each one is given 0.1 meter wide. So you want the initial speed with which it is launched. So it's a horizontal projectile launch. Horizontal projectile range formula is u root over 2h by g. Range is 0.4. U into root over 2 into the height we got also 0.4 divided by g is 10 over here. So u comes out to be equal to, so this 0.4 you can put as a 0.4 on this side. So root over of 10 into 0.4 divided by 2. So you can see it is 4 divided by 2. So u is equal to root 2 meters per second. So we have to represent as root x. So x is equal to 2. That is the answer. Let's start with the next question. It says an electron is moving under the influence of the electric field of a uniformly charged infinite plane sheet S having surface charge density plus sigma. Electron at t equal to 0 is at a distance of 1 meter from S and has a speed of 1 meters per second. Maximum value of sigma if the electron strikes at S is equal to t equal to 1 seconds is how much? Now there is one thing that you have to understand over here, and that is the speed is directed opposite to the acceleration, initial speed. So they have not told you anything about the speed, but how do you determine? So if suppose the electron has to go down and hit here by 1 meter, its initial speed is upwards, and then the acceleration slows it down and brings it down. How do I know that happens? How do I know that the velocity is opposite to it? That is because if you see, it has to travel a distance of 1 meter and its speed is 1 meters per second. So if it strikes S in 1 second, then you can clearly tell that there is no acceleration, because this S is equal to V into T. But we know in an electric field, you have a certain acceleration. Of course, you have a certain acceleration. So the only possible case is if this initial speed is directed in the opposite direction. So initial speed directed upwards, the 1 meter is from here. So once the acceleration acts down, it goes up, acceleration then pulls it down. That is the only way you can justify it. So from that point of view, you can go with S is equal to minus ut plus half at square, because initial speed is upwards. So S is given as 1 meter, u is 1, time is 1, plus half into the acceleration is, we'll keep it a, we'll find that, and the time is 1 square. So this is 1 comes here, so 2 is equal to half into a, so a comes out to be 4. A comes out to be 4 meters per second square. Now where does this acceleration come from? The acceleration comes from the electric field acting with the charge. So the electrostatic force. We know the electrostatic force Fe is equal to Q into E, or rather since we are dealing with an electron, we can just call it E into E, charge of an electron into this. It's an infinite plane sheet. So the electric field for that, if its surface charge density is given as sigma, then that is sigma by epsilon naught. That's it. That is the force, the electrostatic force. So the acceleration that it leads to is E sigma by m epsilon naught, force by mass, and that acceleration is 4 meters per second. Right away it's 4 meters per second here. My bad, I missed out on the 2. So it's sigma by 2 epsilon naught, that's the electric field for a single sheet. For 2 sheets it might have been sigma by epsilon naught. We have a factor of 2 here. A is given as 4 over here. Sigma by 2m epsilon naught. So you can see from here that sigma will be equal to, multiply it here, so 8m epsilon naught, 8m epsilon naught divided by E. So this alpha is equal to 8m epsilon naught divided by E. Next question says a cylinder is rolling down on an inclined plane of inclination 60 degree. Acceleration during rolling will be x by root 3, where x is how much? So we know the direct formula for acceleration during pure rolling down an inclined plane. It is given by A is equal to g sine theta divided by 1 plus k square by r square, where k is the radius of gyration. So k square by r square for a cylinder, this is a solid cylinder I am assuming, k square by r square is equal to half. We put that in here, g into sine of theta, sine of 60 divided by 1 plus k square by r square is equal to half. So we have g is 10 into sine 60 is root 3 divided by 2 multiplied with, this is 3 by 2. Cancel the 2's out, put this root 3 here. So we have 10 divided by root 3. So this x is equal to 10 root 3. X is equal to 10. This is g will be equal to this, where x is equal to 10. They have technically given an answer in a way, but it's in the question it's actually g given as 10 meters per second square. Next question says, in a double slit experiment shown in the figure, when light of wavelength 400 Newton meter is used, dark fringes are observed at P. If d is equal to 0.2 meters, then the minimum distance between the slits S1 and S2 in millimeters is how much? So over here, you want it at point P, right? You have S1 and S2. So this is your S2 and this is your S1. The source is here. So even before the light ray reaches S1, it has already traveled an extra path difference. So over here, if you think about it, this is going to be root over of capital D square plus small d square. So the light ray that goes from here and back here, the distance it travels is 2 root over capital D square plus small d square. And the distance it has to travel from the source to here through this slit is 2 into d. That is the path difference. And for there to be a dark fringe, that path difference should be equal to lambda by 2. That path difference should be equal to lambda by 2. Now all you have to do is finally find out what the small d is from here. So first and foremost, d square plus small d square is equal to lambda by 4 plus d. I took the 2 common here and sent it down to make it lambda by 4 plus d. So capital d square plus small d square, I squared both sides. Here I'll have lambda square by 4, or let's just keep it, yeah, lambda square by 4 plus 2 into lambda capital D by 4, 2 into lambda by 4 into capital D plus d square. Cancel out the d squares on both sides. This will be lambda square by 16, my bad. Lambda square by 16. Cancel out the d squares on both sides. So small d is equal to, you can see this lambda squared is technically going to be much less. You can technically ignore the effect of this. You can technically ignore the effect of this and just put that d square is equal to, just this part I'll bother about because this quantity is going to be very small as compared to the other one. So I'll just put the 2 here. So lambda is 400 nanometer, was it? 400 10 to the power minus 9 divided by 2 into d was given as 0.2 meters. 0.2. Cancel it out. It will leave behind a 0.1 that I make this as 10 to the power minus 10. So d square is 400 into 10 to the power minus 10. So d becomes equal to 20 into 10 to the power minus 5. We are looking for it in millimeters, so it would be equal to 0.20 in millimeters. That is your small d, the distance between the slits. Next question says that when a hydrogen atom is going from n equal to 2 to n equal to 1, it emits a photon. Its recoil speed is x by 5, where x is how much? So this is pretty simple, because as soon as it emits it, it's technically whatever is the momentum of the photon, that is going to be the momentum of the hydrogen, because it's like a recoil velocity. Momentums will be equal. Okay, so the momentum of the photon, we want the momentum of the hydrogen is equal to the momentum of the photon over here. We are looking for the velocity. So velocity of that hydrogen is equal to momentum of the photon divided by the mass of hydrogen. Divided by the mass of hydrogen over here. How do you get to the momentum of photon? You can get that from the energy. The momentum of the photon I write as h by lambda by de Broglie divided by mass of a hydrogen. Multiply a c in the numerator and the denominator. Then hc by lambda would refer to the energy of the emitted photon. It would refer to the energy of the emitted photons. It would be E by mh into c. How do you get the energy of the emitted photon? To get that, E is equal to 13.6 in terms of electron volts into 1 by n1 square minus 1 by n2 square, which is 13.6 into 1 by, from 1 minus 1 by 4, 1 by 1 square minus 1 by 2 square, that is 3 by 4 times of 13.6. So we can put that in here. 3 by 4 times of 13.6. It was in electron volt, so 1.6 into 10 to the power minus 19 divided by mass of hydrogen is 1.6 10 to the power minus 27 multiplied with the speed of light 3 into 10 to the power 8. Cancel this 1.6. This cancels with this, leaves behind a 10 to the power minus 19. That takes this out. This 3 goes out with this 3. So you are left with 13.6 divided by 4. So 13.6 divided by 4 can be written as, it would go with I believe 3.4. It would go with 3.4. So this will be equal to 3.4. Now I have to write it as x by 5. So I multiply a 5 over here, divide a 5 here. So 3.4 into 5 would be 17 divided by 5. So x is equal to 17. That is the answer. So I believe that was the last question we had for this shift. We will be having the other paper solutions also for the following shifts. So thank you all students so much for tuning in for this session. See you all again in the next paper discussion.